here we're verifying trig identities. So we, you actually can show me what you start from one side and move to the other side. Okay, if you want to start with sine and go this way, it's okay. This is there's a what's that called, reflexive property of algebra. But this we can start with here and go that way. So it's kind of up to you. You just have to show that they do equal each other. Okay. Now what I like to do is actually start with the more complex thing to get to the simpler thing. It's just easier to do. It seems strange, but that is the case. If I started with sine, like, how do you manipulate something so simple to get it to something more complex? So start with the complex, go simple. Now what I do know is I do know a property of tangent. I do know that it is sine over cosine. Okay. Okay. And then that is going to multiply to cosine. All right. And then what you need to show is just that these two cancel each. Let's put that over 1. Show that these two cancel each other out, and you get sine of x. Okay. It's that simple. That's all you're doing. Showing me one step or 2 or 3 to bring you the complex to the simple. Okay. It's a really good skill to know as you move farther along in mathematics. Okay. And of course, I'm going to assume that you are going to. Okay. Even if you tell yourself you're not, you never know when you're going to need it. Okay. What kind of path you would choose. All right. So these guys look about the same amount of complexity. So I'm going to just start with the left and see if I can just move it over to that. Okay. So what I'm going to do is I'm going to go secant, and in my first step, I will actually am going to write what secant is as a reciprocal of. So that would be 1 over cosine x over, and then cotangent is cosine x over sine. Okay. Now what this step is showing us is that we can now create a fraction divided by another fraction is the fraction multiplied to its reciprocal. Okay, so 1 over cosine x times the reciprocal. And of course there's 2 of them. Okay, so sorry about that. There's 2 of each. Okay. All right, so, okay. What we have here then is, believe it or not, this is the final step. These guys right here, that is tangent. Okay, that is tangent. And then this guy can just stay because he is exactly what you need here. Okay, so I'm not going to be making these very difficult. I just want you to remember some basic properties. Remember that you can flip the reciprocal functions, and then remember that tangent is sine over cosine. That's kind of very, very important for those of you going into calc next year. Okay, it happens a lot. So this right here as a bundle is just tangent. Okay, squared x, and then these guys are bundled into him, so you just got this guy left over, and that's it. That's all you had to show. Okay. All right. Next one. All right, this is a little crazy here, but you know, I could possibly turn this into a something involving cosecant effect. You might, I see something different, but you know, there might be another way that you could get to this. What I'm going to do is I'm just going to automatically turn them into sine and cosine. Okay, so this guy would look like 1 over sine x minus cosine squared over sine squared. Now that's cotangent squared, so both of these guys are going to be squared. And that's going to be all over 1 over sine squared x. Okay. Now that we got all cosines and sines, this is great. I'm going to go ahead and give this guy a sine because I need a common denominator here. So let's give this guy a sine. And that would be a sine x, and then he would be squared. So now I got sine x. Now they have a common denominator. Okay, now that's good because that's kind of where, that's definitely where I want to go. And so now I want to have this guy. He's still there underneath, but now I'm dividing by 1 over sine squared x. Okay. Now remember, if I'm dividing by a reciprocal, it's the same as, if I'm dividing by a fraction, it's the same as multiplying by its reciprocal. Okay. And so we just have one more thing to do here. Times 1 over would be that over 1. So that made no sense when I said it, but this guy multiplied by its reciprocal would basically force those two to cancel out, and that is precisely what you've been looking for. Okay, that is your final answer. Okay. All right, now the only other, just remember, those of you watching the video, great, you reached the end. Just know that this, not the end. I'll do. I can graph circles real quick. This one right here, do remember that one. Okay, you don't have to remember the, because I forget it often. I think it's what is it? 1 plus cotangent squared equals cosecant squared. Yeah. Okay. And then the other one is like tangent plus 1 equals secant squared. You don't have to remember those. Okay. You might have to look them up next year, but that's okay. Just do remember this one, though. That's super common. All right, now we're totally jumping into conic sections now, and we are looking for what conic section is this? Is this what shape? Now, I see that it's equal to 1, which means it could be a hyperbola, an ellipse, or a circle. And in this case, it is a circle because there is nothing being divided by. Okay, there's no fractions here, and it looks like I have addition. Okay, so this means it's perfectly balanced. It's a balanced ellipse. So what we do is we just look at here to tell us how far to the right or left we move, and we did move positive 4 here. And then this guy says I'm not moving up or down because it's like y minus 0. So right here is the center. I'll darken this up. Right here. And I need a radius of 1. What we're saying is r squared equals 1. So if I were to take the square root of both sides, I would get r equals plus or minus 1, but a negative radius doesn't make any sense for us. So we just have a little circle right there. Okay. Now when we do this one, what we've got to do is we have to complete the square. Okay, and this is CDS, and you might have forgotten it because it's a weird one. It's a weird process, and it's pretty exclusive. You only use it for conic sections, really. Sometimes with quadratics, but you always have the quadratic formula with you. So if you remember that, it looks like this. You put the y's with the y's and the x's with the x's. Okay, and then we're going to move that 3 over to the other side. Okay. Now, what we need is a perfect square trinomial, something that looks like this, okay? Something quantity squared. And with that 4x here, that doesn't allow us to have a quantity squared. So what we have to do is we have to use a special formula that is embedded in the completing the square. That's what it means to complete the square. We take the b value of a quadratic, which is 4 in this case. Over here it's negative 6. We would divide it by 2, so just cut it in half and square it. All right, now that's going to give us 4. Okay, now I just added 4 to the left-hand side, so don't forget to add 4 over here. Okay, I got to keep the balance. Now also over here, I've got a negative 6, but I got to divide him by 2 and then square it. That's how completing the square works. So that'd be 3 squared, that's positive 9, so we're going to add that to this side. So now over here, I've added a positive 9. Now what this does is it gives me two perfect square trinomials, and this guy was the 9. Okay, and so this is exactly my goal because I know that it's a circle, but its center moved. Okay, these guys forced it to move away from the center. Okay, the 4x and the negative 6y forced it to move away from the center. So I have to find out through completing the square where it adjusted to. All right. So what I do is I just take the square root of x squared. Okay, take the square root as you go down here. Okay, take the square root. Take the square root. Okay, and then whatever sign this is, just put it right there. Negative, put it right there. Okay? And all you're really doing is you completed the square so that if I FOILed this out and did x plus 2 times x plus 2, I would get that. If I did y minus 3 times y minus 3, I would get that. Okay? So this tells us then that we moved to the left 2, and then we went down 3. And it also tells us here that if I took the square root of this r squared, I would get my radius. So this would be 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4. All right, and that is it. Now notice then that this whole page is now just the 3 other shapes, okay, and that will be in the next one.